All right, today's lesson is 9-7, factoring special cases. If you remember back to a previous lesson, 9-4, we had the perfect square trinomials. You had three different formulas to remember and to write down. A squared plus 2ab plus b squared. Those were our end products. Remember, those came from a plus b times a plus b. That special case looked like a plus b squared. We'll use that later on as the others in our lesson, just working backwards. A squared minus 2ab plus b squared. That factored out to be a minus b times a minus b, which can be rewritten as a minus b squared. And then with no middle term, where that drops out, a squared minus b squared. That's where you have a minus b times a plus b as your factored form. And we're going to get to these three on the next few slides. Our first problem that we'll work with under factoring a perfect square trinomial with a equals 1. Remember, a is the coefficient to your first term. I want you to factor m squared minus 6m plus 9. Remember, this is going to be under the form a squared minus 2ab plus b squared. Hopefully by now you can see that you've got your m squared, which would be easy to factor, and your 9. It's a perfect square. M squared would be m times m. 9 would be 3 times 3. So we're going to factor that trinomial into our two binomials. The m and m would be your first two terms. The 3 and 3 will be your second terms. And your signs will have to be both negatives because of your b here. And then whenever you rewrite that, you could simply write that as m minus 3 squared. M minus 3 times m minus 3 gives us m minus 3 squared. Let's try that on another one. X squared plus 8x plus 16. Remember, when you factor that, that's a squared plus 2ab plus b squared. X squared can be broken into x times x. 16 is a perfect square. Its factors are 4 times 4. So to get our binomials, the two first terms would be x times x. X here, x here. Our second terms would be 4 and 4. So to get our signs, b is positive. So we've got plus 4, plus 4. So our answer would be x plus 4, or to shorten that up, x plus 4 squared. Now with the special case of a perfect square trinomial with a that is not 1, we're going to work basically the same way. This is a squared plus 2ab plus b squared, 16h squared. Well, we know h squared would be h times h. What about 16? That would give you 4h times 4h. 25 could be broken to 5 times 5. So for our binomials, our first two terms are going to be 4h in both binomials. 5 will be our second term. And our signs are both going to be positive because b is positive, or your middle term is positive. And that can be rewritten as 4h plus 5 squared. Again, another example for a perfect square trinomial with a not equal to 1. 9g squared minus 12g plus 4. 9g squared. The g's would break down to g times g. 9 would be 3 times 3. So together, 3g times 3g would give you 9g squared. 4, that would be 2 times 2. And then, to break that up into the two binomials, you're going to have 3g in the first spot, 2 in the second spot. What about your signs? Middle term is negative, so both terms here would be negative. So 3g minus 2 times 3g minus 2 is your answer, or we could rewrite that as 3g minus 2 squared. Now, what if we don't have a middle term? The difference of two squares for a equals 1. So if the middle term drops out, look back to that first page. Something special has to be true about our binomials. One's going to be negative, one's going to be positive. A squared gets broken up to a times a. 16, that's 4 times 4. Look at that. There's your answer. A minus 4, a plus 4. As always, if you don't believe me, use FOIL. A squared minus 16. There would be a negative 4a, positive 4a, and those drop out. All right, let's try that again. M squared minus 100. Want to factor into two binomials? What's true about the two signs if there's no middle term here? That one's going to be positive, one's going to be negative. M squared, that's m times m, 100. That'll be 10 times 10. And that's it. That's all you have to do on those to get your binomials. Well, what if a is not 1? Well, it's the same idea. Two binomials. Again, one's going to be positive, one's going to be negative. 9b squared can be broken up in two. 3b and 3b. 25 is 5 and 5. And there you go. There's your answer. All right, next example on this. 25b squared minus 64. See if you can race Mr. Hare to the finish of the binomial factoring. 25b squared, that's 5b times 5b. 64 would be 8 times 8. And the signs, one would be positive, one would be negative. I won. The last special case that we have to work on is if we have to factor out a common factor. This happened in the end of 9-6 when we had to factor out a 2. If you look at 5x squared minus 80, is there any number that you can take out beforehand? Well, you can take out a 5. So if we factor out a 5 from 5x squared minus 80, what would we have left? We would have x squared there, and if you take 5 from negative 80, you'd have negative 16. Well, if you cover up that 5, x squared minus 16, we just factored those types of problems. Two binomials, x squared would be broken up into x times x. 16 would be broken up into 4 times 4. Remember, if there's no middle term, x squared minus 16, one positive, one negative. But don't forget, you got to bring that 5 down, put it out in front for your answer. So your answer is 5 times x minus 4 times x plus 4. Okay, try to do this one on your own. Factor 8y squared minus 50. Can a common factor come out? Well, it has to since it's in this section. 8y squared minus 50. They share a 2. 8 and 50. And that's it. 50 doesn't have a y with it. So a 2 can come out. You'd be left with 4y squared minus 25. Then to get your binomials, 4y squared breaks up to 2y times 2y. 25 is broken up to 5 and 5. And again, no middle term, so you get one sign of each. And the last thing to remember is to bring down that factored out 2. 2 times 2y minus 5 times 2y plus 5.